Hi, folks. I'd like to introduce you to a project called Whirlwind, which is AI forecasting and super performant weather routing and statistical analysis. My goal here is to convince you that we're in a new era. The old tools are just not going to work anymore, and we can do a lot better than what we've been doing. So first of all, AI forecasts are here. This is not hype or hyperbole. I'm not some company that sells weather forecasts and is just trying to convince you to buy a better forecast but not providing any statistics. We're talking about open science. We're talking about public papers, papers published in places like Nature, research being done by folks like Google and Microsoft, and many of you have maybe even used an AI forecast. For instance, if there's an AI version of GFS, there's the AIFS model, which is the AI ECMWF model. Environment Canada has an AI model. And all of these models are actually versions of Google's GraphCast model that have been retrained and fine-tuned on either the GFS data or the ECMWF analysis or Environment Canada's GEM model. But they're versions of the GraphCast model. And so these models are being taken seriously by the establishment, and they are beating the traditional scores. So just to go back here for a second, don't take my word for this. You can go, first of all, this is the list of models for models that are supported by this project, but you can download the code and run these models yourself. We're also talking about ocean models, and so there's AI ocean models that are outperforming traditional ocean models. So look up the papers, find the statistics in the papers. You'll be astonished how good these models are. But if you want the cheat code, just go to WeatherBench. This is a Google project where they released basically it's code that allows you to verify your AI model against either the HRES analysis or the ERA 5 reanalysis. And you can go here and you can go to deterministic scores, and you can pick the U or V component and look at the root mean squared error. And you can see here that, and root mean squared error, lower is better. And so actually here, as you go out in time, the IFS, the traditional ECMWF HRES, is the worst performing on this page. Now this is 850 millibars. And you can also look at how things, in different regions, what the scores are. And this is for the whole year of 2022. So again, this is not hype. This is not nonsense. You can also go to Scorecards 2020, and they have really good statistics for wind vector, which is direction, and then 10-meter wind speed. And in this case, they're comparing it against the IFS HRES. So the IFS HRES in these cases is white, and if a box is red, it's worse than the IFS. If it's blue, it's better than the IFS. And you can see for all of these AI models, when it comes to 10-meter wind speed, they're crushing IFS. So the models are here. What is interesting about the models besides the fact that they are accurate? We can run them locally on our own machines, and we can run these models, these forecasts, in under a minute on the right hardware. So this puts us into a regime where we're no longer dependent on waiting for the traditional players to generate forecasts and then waiting further to download the data before we can run a route. The new paradigm is you just wait for the analysis. You get the analysis file hours before the rest of the forecast, and a minute after you have the analysis data, you have your forecast. And now you can do that hundreds of times in a row in a day and move to a paradigm where you're just sitting there waiting to download forecasts to you're actually generating hundreds of forecasts yourself in a day, hours before your competition, and the forecasts are better than what the traditional folks are putting out. So that's the world that we live in. I'm not gonna go into detail on this slide, but I do want to call attention to the only downside. What's the downside? What's the problem? Well, we need specific hardware to run the forecast. We need a GPU, we need an NVIDIA GPU, and the bigger the GPU, the better. And so this is not a solution that can just be deployed on, you can't just like update Expedition or Adrena to have these forecasts. You can, but there's going to be very specific hardware requirements. There's very specific memory requirements. And so what we're looking at is a hardware solution. And if you don't believe me, this is just this is 5 AI models compared against the ECMWF quarter degree. In the top left is the ECMWF deterministic at lead time 72 hours. And you can see in all cases of these AI models, there's variation, sure, but they've all propagated the systems in approximately the right spot. There's variation, but it's variation that's within the realm of physical reality. So these forecasts are absolutely amazing. So if the new world is we are generating forecasts ourselves locally on our machines, and we're able to do hundreds of forecasts a day using the analysis from all of the different global models, all of the different global ensemble members, we cannot just be, it can't be the case that we're waiting 30 seconds for a route to complete. The new bottleneck is waiting for routes. So we have to we have to rewrite our routers to be fast and performant so that we can generate tens of thousands of routes a day. And if we're generating thousands of routes a day, now we need better tools to understand the statistics of those routes. The idea that you're going to download one weather model and you're going to, or a small number of models, 5 models, and you're going to run 5 routes and you're going to decide between them, and one of those is going to be correct, and it's going to be correct for the entirety of the course, that's wrong. It's not how the weather works. It's not how the scientists that, meteorologists and climatologists think about weather. It's not how they think about what's going to happen. What we need is a way to understand statistically what are the ranges of possibilities so that we can understand what is possible to happen and the pros and cons of various decisions that we're going to make on the course. So that's what Whirlwind is. So Whirlwind, it's just sitting there downloading analysis files, and it's just generating AI forecasts all the time. We can generate 540 possible forecasts per init time. It takes us a minute to generate a forecast. So we're generating thousands of forecasts a day. We can generate 108 different current forecasts per day. And these are 3-day forecasts or 5-day forecasts. We've written a GPU accelerated router with 500 meter land avoidance, with 500 meter depth mask of the bathymetry, and we're routing trans-Pacific routes in 0.1 seconds. It's also massively parallelized, and so we're scaling up, dozens of polars at a time, multiple models at a time, multiple combinations of weather models and currents at a time, so that we're routing thousands or tens of thousands of routes per day across these hundreds of different forecasts. And all of that is great, but what do you do with thousands of routes? Well, you need a statistical analysis tool, a spatiotemporal analysis tool that helps you understand, make sense of all of that data. And that's what the Whirlwind application really is about. So it's a Wi-Fi application that is hosted on your boat network, and it is the UI that you use. It's device agnostic. Of course, we've got special hardware that's running the routes, generating the forecasts. But the application itself is a web application, and so you can use it from your tablet or an old machine or a Mac or a PC or Linux or whatever. So this is the new world that we're in. And so I encourage you to go to, we do have a YouTube channel. Obviously, you're watching this there. I encourage you to go to whirlwind-ai.com. and you will require a code, and so don't be afraid to request access through our Google form, and we can get a code over to you. But I'm very excited about the future. I hope you are as well, and looking forward to feedback from you. So give it a try. Thank you.